we're going to go ahead and take a look at problem 8.1.19. Looking at this question here about lengths of pregnancies of a certain animal. The population distribution is, the mean is 170 and the standard deviation is 16. So again, this is from the population. Now, what we're going to do in this chapter again is we take samples from those from the population, and when we take samples of different sizes like 19, 71 here, 20, we end up with different distributions because we're looking at the distributions of the samples, right? And the sampling distributions would have the mean of the population, but it's the standard deviation or the standard error that ends up with different values. So in this first question here, was the probability that a randomly selected pregnancy lasts less than 165 days? The mean is 170, and so 165, right, is going to be somewhere on this side of 170, and so we're looking for the probability that would be less than 165. To do that, we would use the normal calculator, stat calculator, normal, and then you put in the means in there, so 170 would go in there, and then with the 170, the standard deviation is 16 here, and then that it's less than 165, calculate that, and then there's your probability, 0.377. And so there's your value, 0.377. The probability is about 37.7%. And then this question here, interpret what does that mean. If 100 pregnant individuals were selected independently from this population, we would expect 37 to 38 pregnancies, right, to last less than 165 days. Then, so that was kind of what we did in chapter 7, and now in chapter 8, what we do is we take a random sample here. The difference again, we just selected one pregnancy. Here we're going to do a random sample of 19 pregnancies, which means we have a different distribution. Here's the sampling distribution over here. And then from there we see that to calculate, we know the mean of the sampling distribution would be equal to the population mean, because samples are going to be around what the average of the population is. It's just the standard error or the standard deviation of that distribution is going to have a different value, 3.67. And so to answer this question here, you can see what the mean and standard deviation are, or the standard error. What's the probability that the mean of 19 pregnancies would be less than 165? And so the difference here is I'm going to put 0.367 in there, compute that, and then you can see now I end up with 0.087 for the answer there. 0.087 again, because now we're looking at what's the, if the mean of 19 pregnancies is less than 165 days. And so we would expect how many in this case? We would expect about 8 or 9 of those pregnancies. If we have 100 samples of 19, we would expect 8 or 9 of those samples to have a mean less than 165. And the same goes for these other problems here. What if you do a random sample of 71? Then this is, you recalculate the standard deviation. You have the adjusted, which is the standard error. And then in place of that, you would put 1.90 in here. Compute, and then you get 0.004. So you even get a smaller number here. 0.004. And then out of this here, you would expect 0 to 1 of those pregnancies, if you have 100 of those, to have a mean less than 165 if your sample size is 71 pregnancies. What might you conclude if a random sample of 71 pregnancies resulted in a mean less than 165 days or less? We would conclude that this is definitely unusual since this probability is so small there. And then the last question from this problem is, if you do a random sample of 20, there it is, you get 3.58. What's the probability that the mean would be within 9 days of the mean? And so in this case, it's an important question here, 170, 161, and 179. So that's the question we're now answering there, between 160, because that's within 9 days of the 170, from 161 to 179. So in this case here, I would put 161 within 9 days. I got to change that to 3.58 like that, and then compute, and then you get 98.8% for that one there, 0.988. So that's within is an important, what's the meaning of that there?